This is Lab 25, Example 3, Part 2. We want to do Part D. We want to determine all of the zeros of f of x and write f of x in completely factored form. We have f of x up here. In Part C, we were given the information that 3 minus 2i is a 0. So we know that there are zeros, 3 minus 2i and 3 plus 2i. So we know that there's 3 plus 2i and 3 minus 2i, which means we can divide this function out by our known zeros. So we're going to do 3 plus 2i first, using synthetic division. So using synthetic division, we have 3 plus 2i, and it's going to be like this. That. We're going to write the coefficients of our function up here. So we have 1, negative 14, and then we have 78 and negative 206, and then positive 221. And just like any other synthetic division, we're going to bring down the first number here, multiply this number by our number here. 1 times 3 plus 2i is 3 plus 2i. Then we're going to add these two numbers. When you add a real number with a complex number, you add the real bits to the real bits and the imaginary to the imaginary part. So negative 14, you're just going to add it to 3 and carry the 2i. So that's going to give us negative 11 plus 2i. And then you're going to multiply this by this. Now I'm going to show the first one how you would do that. So this is going to be negative 11 plus 2i times 3 plus 2i. And any imaginary numbers that you multiply will be like this. You need to do the foiling method. So the first, inner, outer, last. So 3 times negative 11 is going to give us negative 33. Negative 11 times 2i is going to give us negative 22i. 2i times 3 is going to give us 6i. And 2i times 2i is going to give us positive 4i squared, like that. So I squared, if you remember, I is the square root of negative 1. So if you square this, that means that we have a square root squared, which is just going to give us negative 1. So this is 4 times negative 1. So this is negative 33, and we can simplify this middle part. Negative 22i plus 6i is going to give us, let's see, it's going to give us negative 16i. And this is 4 times negative 1, which is just negative 4. Negative 4 can be added to negative 33. So this is going to give us negative 37 minus 16i. So I'm going to skip over the algebra, and I'm just going to show the synthetic division, but every single time that you multiply a complex number by a complex number, it's going to be just like this. So this is going to give us negative 37 minus 16i. We're going to add 78 to this, negative 37, and carry the negative 16i. This is going to give us 41 minus 16i. Multiply 41 minus 16i by 3 plus 2i. We're going to get 155 plus 34i. Adding this to negative 206, we get negative 51 plus 34i, carrying that 34i. And then multiplying negative 51 plus 35i times 3 plus 2i, we get negative 221. And this added, of course, is 0. So we're left with this. After we take out 3 plus 2i, I'm going to take this these coefficients. These are actually the coefficients of a polynomial, just like these were. I'm going to take this and divide it by our other 0, which is 3 minus 2i. So we're going to take that. We had the coefficients that were left as 1, negative 11 plus 2i, 41 minus, that's a minus, minus 16i, and then negative 51 plus 34i. Very ugly, but... And then we want to divide this by our other known 0, which is 3 minus 2i. So, bringing down the 1 times 3 minus 2i is going to give us 3 minus 2i. So we're going to add these two. Negative 11 plus 3 is negative 8. Positive 2i minus 2i is 0, so this is just negative 8. Negative 8 times 3 minus 2i is negative 24 plus 16i. Adding these, we get 17. And then 17 times 3 minus 2i is 51 minus 34i. And if we add these, we notice our signs are different, so we just get 0. So, we know that so far we can rewrite f of x as follows. We took out x minus 3 plus 2i. That was one of the x's we took out. And we also had x minus 3 minus 2i, which is the 0 we just took out now. And we're left with the factor of x squared minus 8x plus 17. Because we took out, we started with x to the 4th, so we know that we have to have x to the squared. So the only thing left to do is to factor this bit right here. And if you try and factor it normally, you'll have to look at factors of 17. Factors of 17 is just 1 and 17, which none of those add up to negative 8. So we're going to use the quadratic formula for that. Quadratic formula is x is equal to negative b plus minus the square root of b squared minus 4 times a times c divided by 2 times a. So we have our b is negative 8. Negative b is going to give us a positive 8. Negative gives us a positive. So negative b is going to be positive 8 plus minus the square root of negative 8 squared, which is 16, minus 4 times a is 1, c is 17, so this is 4 times 17. I'm just skipping a little bit of the algebra, since we should be familiar with this by now, I hope. And then we divide by 2 times a is 1, so this is just 2. So this is 8 plus minus 16 minus 4 times 17 is negative 4. Square root of negative 4 divided by 2. We can simplify the square root of negative 4 as follows. We have 8 plus minus 4 is the same thing as 2 times 2. So this is 2 squared. We can take out the 2 to the front. So this is 2 times the square root of negative 1 divided by 2. We can factor a 2 out of these top two numbers. So this is 2 times 4 plus minus 1. And then the square root of negative 1 is I. Divide by 2. 2 over 2 cancels. So this is just equal to 4 plus minus I. So we know that we can rewrite our f of x as x, and if I simplify this, this is just going to be x minus 3 minus 2i, x minus 3 plus 2i, foiling this negative 1 here. And then this can be rewritten in terms of this, which is going to be x minus 4 minus I, and x minus 4 plus I. So this is the fully factored form of our polynomial function, and our zeros are x is equal to 3 plus minus 2i and 4 plus minus I. So that's our answer.